What if the most powerful telescope ever built has just shown us something we were never meant to see? What if everything we believe about the origin of the universe, about time, space, and reality itself, is quietly unraveling? The James Webb Space Telescope was designed to look back to the first light after the Big Bang. But instead of clarity, it has delivered confusion. Data so unexpected that even veteran cosmologists are uneasy. One Nobel Prize-winning physicist reportedly summed it up with a chilling remark: "This does not look like our universe." So what exactly did James Webb discover at the farthest edge of existence? And why are scientists warning that it may force a complete rewrite of modern cosmology? In a region of the sky filled with ancient light, Webb detected what initially appeared to be a faint yellow smudge. Nothing remarkable, until astronomers analyzed it more closely. That dim blur turned out to be the most distant galaxy ever observed, forming just 290 million years after the supposed birth of the universe. Here's the problem. It's far too massive, far too bright, and far too evolved. According to current models, the early universe simply didn't have enough time or material to produce galaxies like this. And yet it exists. Worse, it's not alone. Webb has now identified dozens of similarly mature galaxies from the same early era, objects that should not exist according to everything we thought we knew. As researchers examined these anomalies, the mystery deepened. Some of these objects behave unlike galaxies entirely. In normal galaxies, only a fraction of gas converts into stars. But Webb has detected systems that appear to have transformed nearly all their matter into starlight. No residual gas. No dust. Just intense radiation. That shouldn't be possible. Now scientists are asking an uncomfortable question. What if these aren't galaxies at all? What if Webb isn't looking back in time, but looking through something? A relic from a previous cosmic cycle. A structure from beyond our universe. Or evidence that our cosmos is not as isolated as we assumed. To understand why this is so unsettling, we need to talk about cosmic limits. The observable universe is bounded by how far light has been able to travel since the beginning of time. Beyond that lies a region forever unreachable. Nothing from there should affect us. And yet Webb appears to be detecting light and gravitational effects from regions that challenge those boundaries. Signals that should never have arrived. Effects without visible causes. This has reopened debates once considered settled. What if the universe didn't begin with a singular Big Bang? What if time itself didn't start, but transitioned? Some physicists now suggest that what we're seeing may not be the early universe at all, but the aftermath of something older. One of Webb's most overlooked findings isn't an image but a signal. While studying background radiation, its instruments detected a faint, repeating oscillation. It doesn't match pulsars, gravitational waves, or known cosmic noise. The pattern is precise, almost rhythmic. Some scientists believe it could be an exotic physical phenomenon. Others quietly admit they don't know. But the unsettling part remains. The signal follows a mathematical structure, as if governed by rules we haven't discovered yet. Then there's the gravity problem. In several distant regions, Webb has observed powerful gravitational effects, light bending, space warping, without enough visible matter to explain them. This goes beyond dark matter. These phantom mass fields behave like pressure points on spacetime itself, as if something massive exists nearby but outside our detectable universe. Where could that mass be coming from? A once fringe idea is now being cautiously revisited. The possibility of a mirrored universe. A cosmos where time flows in the opposite direction, overlapping ours only at extreme scales. Webb has detected unusual rotational patterns and asymmetries in distant structures, patterns that hint at interference between two different cosmic systems. If true, our universe may not be alone. It may be entangled. And then came the final anomaly. Webb tracked a faint light source at the edge of the observable universe. As expected, it began to fade. But then, impossibly, it reappeared. Same spectral signature. Same energy pattern. As if the light had bounced back. A cosmic echo. Either space is closed and finite in ways we don't understand, or the light encountered something at the edge, something capable of reflecting it. The James Webb Space Telescope was built to reveal how the universe began. Instead, it may have revealed that our universe is incomplete. The impossible galaxies. The unexplained gravity. The rhythmic signal. The echo. Each discovery erodes certainty. Perhaps the most disturbing possibility is this. The universe we observe may be only a layer of a much larger reality. The question is no longer whether we are alone in the cosmos. It's whether we're even in the right one.